Hello everyone. Deleting node from doubly linked list is very simple task. Let's see how to delete node from the doubly linked list.
When we want to delete, again we are deleting at the beginning, at the end, and at intermediate. So we are now going to start with at the beginning. How to do this? It's very simple. What are the steps? First, if list is empty, then display empty list. If list is not empty, then follow the steps. So what steps we are going to follow? Very simple. We are going to create a temporary variable. We want to delete that temporary variable because it is pointing to the start node. Then start is equal to start of write. So start of write means what? See, this is my linked list with two nodes. I want to delete node at the beginning. So this node is going to delete. Now this contains the start node or contains address of the next node. Okay. Now here, what we are going to do, start is equal to start write. So see, it's write contains the address of the second node. So let's say this is 100 and this is, let's make it 200 and this is 100. So here we have address of node, address 200, address of second node. Now what we are doing, we are moving our start from start to start right. That means this next node we are now making our new start. The second node we are making our new start. Okay. And then what we are doing, start of left. Now this is our new node. So start of left is now going to become null. So now initially it was containing the address 100. It was containing address of the first node. Okay, now we are making it to null. So that means now it is not containing address of the first node. This link is now broken. Okay, and then as this link is broken, this node is now ready to free or ready to remove from the memory. So free temp. So this temporary variable is now removed from the memory also. So now we have linked list with only one node. And here, thus we have deleted the node at the beginning of the linked list. Fine. So next, deleting node at the end. Now I'm not showing the animations to you. I hope this animation is sufficient for you to understand because we have already seen a lot of concept with animations. Fine. Now let's talk about deleting the node at the end. So very simple. What we are going to do, we are going to go to the end of the linked list. Okay. And then we are going to delete that last node. So how to reach to the end of the doubly linked list? The nodes next contains the null value. So we have to just find which is the node which contains whose next pointer contains the null value. Okay, so if list is empty, then display empty list. Okay, if list is not empty, then follow the steps. So what steps we are going to follow? First, we are going to create a temporary node. Okay, now see here, this method is to reach to the last node in the linked list. How to reach to the last node in the linked list? As I just told, the last node in the linked list, listen carefully, the last node in the linked list, its right pointer will contain the null value or its next pointer will contain the null value. That's it. So while temp arrow right is not equal to null, जोपर्यंत नोडचा राईट पॉइंटर जो आहे किंवा नेक्स्ट पॉइंटर जो आहे त्याचा कंटेंट नल होत नाही तोपर्यंत नल झाला स्टॉप दी लूप. As soon as it becomes null, stop the loop. जोपर्यंत तो null नाही आहे, till that point keep executing the loop. So what we are going to do here, temp is equal to temp arrow right. That means what? The right node will become our new temp. The right node is going to become our new temp. So this is our first temp. Now its next is not null. So now it's right. This is the right node of this temp node is now going to become new temp. So this is our new temp. In same way, is this right pointer of the second node contains null? No, it contains the address of the third node. So new temp will be temp of right. So temp of right is this. So this is going to become our new temp. Now this third node's next pointer or right pointer contains null. Yes, condition is true. This is true, right? So this is null, condition not equal to null. Now this condition is going to become false. Now we will go to this statement. We want to what? We want to delete what? This node. So what we are going to do, whatever address we have here in the previous of the last node, we are going to we have whatever, see in the second node what we have, address of this last node. So this is what we are going to now make null. This is what we are going to make null. That's it. Okay, so see here, temp of left, this is our temp of left, that means this node and its right pointer. So temp of left and its right pointer, now we are making it null. So this is going to become null. As soon as it becomes null, it has its address entry for this last node is deleted. Now this node is now free to delete. So free temp node. So temp node is now deleted. And now we have linked list with only 2 nodes. Understood deleting a node at the end? Everyone, please reply.
Yes, sir.
I hope everyone is
Yes, sir.
having attention and understanding the things that I'm explaining. Okay. Now the next point that we are going to talk about is deleting a node from an intermediate position. Okay, deleting a node from the intermediate position, that means in between 2 nodes. Okay, so here the list must contains more than 2 nodes. So here we are going to use again count node function to count the number of nodes. Fine. If list is empty, then empty list message will be displayed. If it is not, then get the position of the node to delete. So we have to ask user to please enter the position. So assuming that we have 3 nodes, so node 1, node 2 and node 3, 3 nodes are there, we want to delete this. Okay, so we will count number of nodes. So number of nodes are 3 here and position that we have is 2. Okay, so node counter will return 3 value and POS or position or LOC location is 2 value. Okay, now what we have to ensure the specified position is 2 is in between first node and the last node. If not, then specified position is invalid. So what we are going to do, POS position should be less than node counter. So node counter variable is nothing but having value equal to 3 and POS will have value equal to 2. This is what we have to verify. If it is true, then only, if it is true, that means position is less than node counter, in that case only we will be able to delete a node in between or in an intermediate position, at an intermediate position. Okay, so what steps are there? See here, POS should be greater than 1. Okay, and it should be less than number of nodes, node counter. Okay, so this value is 3, so POS is 2 is less than 3, yes, condition is true, and position is greater than 1, so 2 is greater than 1, yes, both conditions are true. We will go inside the loop. Okay, now temp equal to start, so now temp is nothing but our start node. Fine. Now we have taken one I variable and I is less than POS. Why we have taken this I variable? Because we wanted to reach to the location position of the node. We want to delete 2. Okay, so node 1, node 2, we want to reach to the node 2. Okay, so for that purpose we have taken variable I is equal to 1 is less than 2, yes, condition is true. We will go inside and now we will see start node is nothing but our temp node. We want to make this node as now temp node because we want to delete temp. Okay, so temp is equal to temp of right. So this is our temp of right is this node. Now new temp is nothing but our second node. Okay, and now I is incremented by 1, I is going to become 2. So now whether 2 is less than 2, condition is false. We have already reached to the second node. So here condition will become false and now we will go to this statement. Okay, now temp of right, see here, this is my temp of right is this node, it's left, that means it's left pointer. Now this left pointer was having address of the second node. Now what we want, it should contain address of the first node or start node. Okay, so in that case what we are going to do, temp of left, see here, temp of left contains the address of the start node or the first node, right? So what we are going to do, see here, temp of right, this is temp of right, its left should contain temps left, so it contains temps left. That's it. हा जो टेम्पररी नोड आहे, नोड नंबर 2, त्याचा जो लेफ्ट आहे त्याच्यामध्ये ऍड्रेस कसा आहे, पहिल्या नोडचा आहे. तो पहिल्या नोडचा ऍड्रेस आता कशाला जायला पाहिजे, थर्ड नोडच्या लेफ्ट मध्ये जायला पाहिजे. सो दिस लॉजिक विल डू दॅट ऍक्टिव्हिटी. व्हॉट, temp of right, see temp of right is this third node, third node's left is now equal to temp of left. So temp of left is start node's address. So that's it, objective is done. Now next, temp of left, see here, this is temp of left. Okay, now it's right, temp of left, this is my temp of left. Okay, and it's right, this is the right part of the temp node, that is start node. Now see, it was having what, address of the second node. Now it should contain address of the third node. And now what we are doing, this is our temp node. Temp node's right was containing the address of third node. Now temp of right we are assigning to the right of the start node. See here, right of the start node, that is temp's left. ओके, टेम्पररीचा लेफ्ट कोण आहे, स्टार्ट नोड आहे. मग स्टार्ट नोडचा जो राईट आहे त्याच्यामध्ये काय जायला पाहिजे, टेम्प नोडचा राईट जायला पाहिजे, बिकॉज राईट कंटेन्स द ऍड्रेस ऑफ थर्ड नोड. Third node, so third node's address is now copied in the first node's right. First node's right. Okay, so in this way we have now link in between node 1 and node 3 directly. Clear? Now node 2 is free to delete. So free temp is freed now, and message is displayed as node deleted. That's it. Clear this, how we have deleted a node in between or from a particular position in between the two nodes. Is this clear to everyone? Deleting the node from linked list.
Yes, sir.
Fine. Now let's proceed to the traversing and displaying a list element or doubly linked list elements. It's very simple. When we want to traverse, we start or begin with the start node and we reach to the node whose right pointer contains the null value. So to display the data, we have to traverse the list node by node from first node until the end of the list is reached. How to get the end of the list? A node whose right pointer or next pointer contains the null value. That's it. So what are the steps? If list is empty, display empty. If list is not empty, then follow the steps. What steps? Initialize with temp, then temp is not equal to null. That means temp of right is not equal to null. Then print the data part. Okay, and then go to the right node, temp of right node. This logic will take us to the last node. Okay, and that's it. So step to traverse a list, tell to head. So whatever we have seen in traversing, okay, so in traversing we, as it is bidirectional, doubly linked list is bidirectional. So this step we have seen for traversing a linked list from head to tail, that is start to end. Okay, now in reverse direction. So in reverse direction, what we are going to do, again assign a start node as a temp, then go to the end of the list and then start printing the value and come to the left of the linked list by assigning a temp as the left of the temp, that means left node. That means assuming that this is my linked list, okay, with 3 nodes. So what we are doing, start equal to temp. So temp is now our start equal to temp. So this is nothing but temp variable or temp node. Okay, now temp of right is not equal to null. So temp of right is not equal to null, condition is true. Here temp is updated, now temp is here by using this statement, temp is equal to temp of right. So temp of right is now new temp. Now if it's right, if it's right is not equal to null, yes, it is not equal to null. So now new temp will be here, and now last nodes this value, the right part, right pointer contains the null value. Now this condition is going to become false. Now temp is pointing to the last node, that is third node. Now we will go here. Now temp is not equal to null. So yes, this condition is true, not equal to null. It will go here and it will temp of data. So data part is printed here. It's data part, temp of data. And now temp equal to new temp equal to temp of left. So this temp of left will contain the address of the previous node, right? So this is now going to become new temp. So is this null? No. So this value will be printed, and now temp of the new temp is equal to temp of left. So this is going to become new temp, that is last temp. Its data part is printed, and now we know that its left contains the null value. The star node's left pointer or previous pointer contains the null value. So here its left contains the null value, so temp is going to become null. So now temp is equal to null, condition will become false. Okay, and we have got the data as this is, let's say this is 11, this is 12, and this is 13. So we are going to get value as 13 first, then 12, and then 11 in reverse direction, that is from right to left. Okay, so this is nothing but the steps for traversing a doubly linked list from right to left or tail to head. Okay, understood? So here we have seen both, that is traversing a linked list from head to tail and tail to head, that is left to right and right to left. In case of left to right, no problem. In case of right to left, we need to reach to the end of the linked list and then traverse from end to first, end to start. That is what we have to do. Is this clear? Traversing a linked list? Please reply. Traversing
Yes,
and
sir.
displaying the linked list elements. Now the last, counting the number of nodes. So it's very simple how to count the number of nodes. Simple logic here we have. If start equal to null, that means we don't have any element, any node in the linked list, that is 0. And if we have, let's say, if that start is not null, so we are going to increase the value of the counter. So same I'm doing here, 1 plus recursion method is used here. You can have just put here I plus plus, return I plus 1 2 3, just count the number of nodes. Okay, so here recursion is used. What will happen here? Start of right, assuming that we have 3 nodes. Okay, so node 1, node 2, and node 3. So it will go to else part because start is not null. Okay, now return what? 1 plus count node start of right, so it will go to the start of right, that means this. Oh, so is it null? No. Okay, so it will be 1 plus, then again 1 plus start of right, that means this is going to pass. Now see here again we will get 1, and now its right will contain the null value. Okay, so it will pass now null value, so at the end it will return 0. So it will return 0 plus 1 plus 1 plus 1, so it will return 3 value, return 3. So because we have here 3 number of nodes. Okay, recursion we have already seen with stack, so I hope you all will understand this, and I have already explained here what will happen. Clear here? Counting number of nodes with this recursion method? Yes.